goes back to like Thanksgiving. Okay? Yeah, well before Christmas. Thanksgiving. That's when people are all finished with their Halloween, they're finished with their Thanksgiving stuff, and they start looking forward to the holidays. Well, Thanksgiving time, that is my traditional time to sit down and write my letter to Santa Claus. I write my letter every year to Santa Claus. Dear Santa Claus, I've been a good boy this year. This is what I want. Now, isn't that the way it's supposed to go? You're a good boy, or good girl, in my case, boy. You write a letter expressing how much of a good boy, maybe even give a couple of examples, and you write down the list of things that you want, and then come Christmas Eve, Christmas morning, you get what you want, right? Isn't that the way that they tell you it's supposed to work? Yeah. So there's a contract. I uphold my half. I'm a good boy. I write my letter, tell Santa Claus what I want, and he does his half. He gives me stuff. Christmas comes along, nothing. It's as if he never read my letter at all. Okay? Breach of contract. This is unfair, and it is not right. So, here's what I did. Starting at Christmas time, up until about 2 weeks ago, I started planning, scheming, drawing up diagrams, doing math, crunching numbers, learning advanced physics and calculus and trigonometry, working late at night, light coming from underneath the door in my garage, that kind of stuff. Right? Just this mysterious banging, clanging, and welding noises coming from my garage. Until everything came together this past weekend. This past weekend, everything was finished. It was all ready to go, ready to rock and roll. And here's what I did. Now, I am not the greatest mathematician, so just to keep the math as simple as possible, here's what I did. Here's the Earth, and the math works out rather nicely from the equator. So the equator is the middle of the world. So here's what I did. I built myself a super snowball cannon. Nice. And I brought it down to the equator. Also, we got a lot of snow this year, so what I did was I made the perfect snowball. About this big. Perfectly round and spherical, smooth on all sides. I just spent months crafting this thing. Keep it in the freezer, craft it a little more, make some measurements, scan it with a three-dimensional computer rendering machine, and all that other kind of stuff. I had to FedEx the cannon down to the equator because you can't bring snowball cannons onto the airplane. And I shipped it down to the equator. And the equator, once again, because math work is nice and simple. So here's Santa Claus up at the North Pole, and here's my super snowball cannon at the equator. Now, I do realize that the equator is rotating with the rest of the Earth once a day. And if you do the math, it works out to be about, at the equator, you're going once a day around. And I had to wait until I rotated just around until I was exactly perfectly underneath the North Pole, waited for the crosshairs to just line up in a fat little elf's belly. I launched the snowball. And it goes flying. Now, according to my math and calculations, it was supposed to take exactly 1 hour to go from here to here. Strike Santa Claus right in the middle of the forehead. 1 hour. One thing I forgot to take into consideration. In that hour's time, me and my cannon have moved about 1,000 miles off to the side. So an hour from here to here. Now what does that have to do with the snowball? Well, the snowball stays directly in front of the cannon at all times because the snowball gets shot out of the cannon, right? So since it gets shot out of the cannon, the snowball flies in a straight line. But it stays directly in front of the cannon. So an hour later, the cannon is over here, 1,000 miles over. The snowball is directly over there. I have missed Santa Claus by 1,000 miles.
Close.
Right? Yeah. He did the Matrix deal. He did one of those deals. So I just missed him by 1,000 miles.
You should see that 1,000 miles earlier.
Yeah, I should have. Well, you only get one shot. I only brought one snowball. Okay, so what happened was the snowball followed a path like this because it stayed in front of my cannon. It's kind of like taking a fushigi ball, and if I take it and I throw it straight up and down into my hand, it goes straight up, comes straight down, lands in my hand. But if I start walking, the fushigi ball and my hand are moving at the same speed that way, right? Now if I take the fushigi ball and I pop it up into the air, it stays directly over my hand. So if I have a super snowball cannon and the snowball is inside the cannon, and if the cannon is moving this way, then both the snowball and the cannon are moving at the same speed. If I launch the snowball, it stays directly in front of the cannon because they both start out at the same speed. You follow? Okay. So it took this curving path like this. Now, Santa Claus, being the vengeful elf that he is, he already has his own super snowball cannon. Now, you don't just go down to the equator, launch a snowball, hop back on the airplane and come back. No, they don't have planes back to New York every single day. So I had to wait a whole day. And while I'm waiting a whole day, I come around the Earth again. Santa Claus waits for me to get directly underneath him. Now, he has got no problem because he's standing still. He doesn't have this whole snowball moving the same speed as the cannon because everything is standing still. So he waits for me to get exactly, directly, perfectly underneath him. He launches his super snowball cannon, and his snowball, in fact, travels a perfectly straight line like that. Took an hour. In that hour's time, I was over here. The snowball splashed harmlessly behind me out into the Pacific Ocean. Okay, if we reset this back to the beginning, here I am directly behind Santa Claus. His snowball splashed 1,000 miles behind me, and it followed a path over the surface of the Earth like that, also a curving path. There's something interesting about this. My path went like this. His path went like this. It looks like one's going to the right and one's going to the left, but if I get in a car and drive, which way does the driver have to turn the wheel? Right. If you're from Santa Claus and you're following a snowball, which way does the driver have to turn his wheel? He has to turn it to the right. Right? This is a right turn for the car. Okay, from your point of view, it's left, but from the driver's point of view, from the snowball's point of view, it turns to the right. So, I did a little bit of Googling after I got back home. And I found out that this is not a new problem that I just came up with my super snowball cannon to shoot Santa Claus from the equator up to the North Pole. This is actually something that goes back quite a few years. One well-documented case of this goes back to World War II. The Germans had a super cannon, not a snowball cannon, just a cannon. A super cannon. And this cannon was able to shoot shells, explosive shells, tens of miles. I don't know exactly how far it was. I don't remember the number from Wikipedia. But it was able to fly several tens of miles. And what they found out was that even if they had the crosshairs lined up exactly on their target, even though they couldn't see their targets over the horizon, even though they had it lined up perfectly with their target, it always pulled to the right. And it always seems like they pulled to the right. My snowball pulled to the right. Santa Claus's snowball pulled to the right. The German guns pulled to the right. So this is something that's actually been documented for a couple hundred years. The first guy to discover this and describe it, his name was Coriolis. And Coriolis says that because we are going over a curved, rotating surface, even though our snowballs are flying in straight lines, the geometry of it makes them curve in a rightward direction in the northern hemisphere. So what would happen is If you're going north, it curves to the right. If you're going south, it curves to the right. If you're going from west to east, it curves to the right. If you're going from east to west, it curves to its right. Every one of these, if you're on the car, you're driving into a right turn. In the southern hemisphere, it works the opposite way. We don't need to memorize anything about the southern hemisphere because, as far as I know, nobody has any buses that go from the southern hemisphere up to here every day. So as a result, we can just say that the southern hemisphere does the opposite. We just need to know about the northern hemisphere, where everything turns to the right. Down here, see, it's just the opposite. So that's what I have to say about Coriolis effects. And I'm going to submit this to the courts. That's right. Is this thing on?